Welcome to this video. So in this video I'll be showing you on how you can sketch a pad footing and do its bar bending schedule and do other calculations. So the first thing that we're going to look at is the sketching part. So in order for you to sketch a pad footing, you need to draw these three elements that are here, which is this thing here, this one here, and this one here. Now, in your sketching, there are some details that are needed. For example, you need to give names to reinforcement, you need to give dimensions, and you need to give annotations. And usually when you are required to sketch a pad footing, you would be required to draw a plan section and a plan view and a section view of that particular pad that you're dealing with. Now, a pad has elements that comprise it. For example, we have its base. So for example, here the base would be this thing from here to here, which has a distance or a length of 450. Then it also has a kicker height. Then after a kicker height, it has this thing that is attached from the top of the kicker height here to where the column is ending. So this thing here is called the column. Now you need to show how reinforcement is put inside a pad footing. Now the first thing that you would need is a planned view, and the planned view would look something like this. So this is the plan view of a pad, and you need to do this exact same thing. Now, in a plan view of a pad, the main thing that are going to be shown will be the reinforcement, one running along the horizontal axis, the other one running along the vertical axis. Now, when you show them like this, remember that you need to leave a space here, which is the concrete cover, and again you leave a space here, which is the concrete cover. This side is spacing for the concrete cover, and the space here for the concrete cover. This line must never touch this bottom base, this bottom part of the base, or this top part of the base, or this side or this side. They must be in freeform state, like the way it is here. So the space here, the space here, space. Then after you've drawn these two reinforcements, you need to draw at the center of your base. For example, the base here was 1500 by 1500, as you can see here. At the center of it, you need to put the column part of your pad footing. And remember that the column, I said it's this part here. This is the column here at the top. So now you need to show it. You show it by putting down its dimension. So for example, the column that we were dealing with here had dimensions of 300 by 300. And this is the one that is in red here. So this is the column. You just show it like this. Then, once you've shown your two reinforcements, you need to show that these reinforcements are being distributed, because remember that these reinforcements are also known as distribution steel or distribution reinforcements. So now the way you show that is that you put a dot, like you are seeing here, the red dot. Then after that you draw this arrow, but this arrow must never touch the side of the base. It must just be in free form. It should be at the same level with this rebar here. Then you drag it down, you draw the same thing again, you draw your arrow just like this. Then this whole thing here, the one in red, it shows that this reinforcement is being distributed along this axis here, which is the horizontal axis. So it's being distributed along the horizontal axis at the specified spacing. So now, for example here, the spacing that we're going to be dealing with will be 150. So you're showing that this reinforcement is being distributed at a spacing of 150. In which direction? The horizontal direction, coming down here. This is what this means, and you must always show it in your sketching. Next up, we have this reinforcement that is in the vertical direction. A reinforcement in the vertical direction will be distributed along the horizontal axis. Now, this one, since it's being distributed from right to left, this vertical one, what you're going to notice is that it's going to be moving along this distance here. Now, this distance can be changing now. It's just that in this case, we have got a pad footing that is 1500 by 1500. But now you might find to say that this span can be a little bit longer in some cases, whereby you can have something like a 2000 here 1500. So now, this reinforcement is being distributed in this direction, from left to right. Now, for you to show that it's being distributed from left to right, what you need to do is that you need to put this dot here, just like you did in this reinforcement. You put a dot here, you draw your arrow, remember, must never touch this part of the base. Then after that, you drag it out. Again, it shouldn't touch this part of the base. It should just end here. Then after it ends here, you are now showing to say that, okay, these reinforcements are being distributed from right to left. That's how you do it. Then next up, it's dimensions. You need to give dimensions to everything that you do in drawings. So for example, your base from here to here is 1500, the dimension has been shown. From here to here, it's 1500 again, the dimension has been shown. Then you also give dimensions to your column at the center. So for example, in this case, we had a 300 by 300 column. Then next up is that you need to give a name to your reinforcements, and this is very, very important. The way you can do that is that you can pluck a line from here, you just drop it down, or from this same line that you had done that is showing that the reinforcement is being distributed, you just drag it out. Then after dragging it out, you give a name to the reinforcement that you're dealing with, and you need to assign bar marks and the spacing as well. So now, in order for you to give a name, the thing that you need to do is that you need to calculate first the number of reinforcement that are along that span that you're trying to calculate the reinforcement for. So for example here, we're going to have this one in the vertical axis. So now, the one that is in the vertical axis here is being distributed along this direction, right? And we have this one in the Y, which is being distributed along the vertical direction from top to bottom. So from here, it's coming down like this. Now, when you are naming, you need to know the number of reinforcement in order for you to give a proper name. Now, you need to calculate the number of reinforcement. And how do you calculate the number of reinforcement? So now, in order for you to calculate the number of reinforcement, you need this formula here, which is the length minus the concrete cover divided by the spacing plus 1. That's the formula for the number of reinforcement. So now, let's calculate for this one in red here. This thing here, this reinforcement that is being distributed from top to bottom. Now, this one here, the distance that we get, the length from this top to this bottom, it's 1500 here, right? So you are going to have your 1500 here, minus, now remember that this reinforcement, it's having a concrete cover here and here. On both ends, it's having a concrete cover of what? 50. So we're going to use 50 as our concrete cover. So we're going to have a concrete cover of 50, 50 on both ends. So now, that's why here we're multiplying 2 by 50. Then, like I said, you divide by the what? The spacing. The spacing that we're using in this case is what? 150 for this distribution reinforcement. So we're going to say 1500 minus 100 over 150 plus 1. We get 10.33. Then, like we always say, we say that you need to round off to the nearest whole number in order for you to get the number of reinforcement if you get a number that has got decimal points. So for example, in this case, we're going to say, since this is 10.33, the nearest whole number is what? 11. So as a result, we're going to have what? 11 reinforcement. Now, this is the 11 that you're seeing here. So it's 11, which is the number of reinforcement. Then you need to look at what type of reinforcements have been mentioned that are running along this span here and are being distributed from top to bottom. So now, we were told that in this case, there are what? Y12 reinforcements. So the Y, it's the high yield strength. The 12, it's the bar diameter, the diameter of the rebars. Then you put a dash. The next number that you're going to write will be your bar mark. Then after you've indicated the bar mark, so for example, in our case, this is going to be bar mark 1. You're going to put another dash. Then you write your what? Your bar spacing. The spacing that you're using, so for example, in our case, we're using the spacing of what? 150. This B1 is not really necessary when you're doing your sketching. So we'll end here. So this is going to be 11Y12-01-150. So you would have named your what? Your reinforcement here. This reinforcement that is being distributed from top to bottom. Then, after that, you have a reinforcement that is being distributed from left to right, which is this one here. So now, you also need to give a name to this reinforcement. Now, the name, how do you give it? Remember that you have to do the calculation of your what? The number of bars. So now, to calculate the number of bars, this one is being distributed in this direction. You're going to get the length that is in this span from left to right. And that direction is what? This here, which is 1500 millimeters. So you do the same thing again when you want to find the number of bars. So you do 1500 millimeters minus 100 divided by 150 plus 1. You get 10.33. Then remember that you're rounding off to the nearest whole number. You're going to get what? 11. This is where the 11y12 came from. Now, y12, why? Because this reinforcement is also what? y12. But if, for example, we're given a reinforcement that is y25, we would have put y25 here. Dash. You put your dash, then after putting your dash, this is a second reinforcement that you're giving a name to. So you're going to give it a bar mark of what? 2. So this is bar mark 1, then you have bar mark 2, dash the spacing, which is what? 150. Yes. Then after that, when you give your names to this and this, you dimension everything. The only thing that we are remaining with is just showing your section point. So for example here, the section point is that we're going to cut from here, coming straight up to this point here. So when you cut, this becomes your section called section what? AA. So for example here, because we've given it names A and A here, and we're cutting at the middle. And remember that your section must always cut through this column that is on top of your base. It must always cut through this column. Then once you've done all this, you're just supposed to give it a name as what? Plan view. Once you do that for your base, you would have been done. Then after you draw your base, the next thing that you're going to talk about will be the section. This section that you had cut across. Now, in your section, the first notable thing that you're supposed to think about is the thickness of your base. So for example here, we have a span, and since we're cutting in this direction from left to right, we're cutting here, from here going straight to this space here. So now when we cut here, what we're going to remain with will be reinforcement. Now remember that this reinforcement, since we're cutting in this direction, we'll cut this one here. So as a result, on your section it's going to appear as dots, then this one will appear as a straight line, just the way it is. So the span that you are given here, sorry I forgot to mention this, the span that you're given from this corner to this corner is 1500, right? So this will be your span here at the bottom. So from here to here it's going to be 1500. From here going to the top it's going to be 451, because 450, that's your thickness that you are given. Then once you move inwards and move up before you go to the collar, this distance here is called the kicker height, and usually it's given as what? 75 millimeters. Then after you have your 75 millimeters, you are now going to have what we call a lap length. The lap length is the distance from the kick height all the way up to the next member. So for example, if there was a slab on top here, it's the distance from the kicker height going all the way up to the slab. And usually the lap length is given by a formula of ND. The D is the diameter, the N, it can be any number that will be given. So for example, in our case, we were given a number of what? 40D. So this thing here, this 40D is the lap length. This is what is known as the lap length. So the D here is the diameter of what we call the starter bars. Now, starter bars are these reinforcements that enter through the column and spread out into the base. So you've seen there's this reinforcement that is coming down like this. Then it bends here and goes to your right. Again from here, from the top, bends going to your left. So these are known as starter bars. So now, in this formula for the lap length, the D is the diameter of your starter bars. So in this case, we had Y16 starter bars. This is the reason why we had the 16. So 40 by 16, you get a 640. The 640 here is going to be your lap length. So now, like I said that these are starter bars. So now when you show your starter bars in your section, this leg length, this is what we call a leg length. You've seen this 500 here. So this 500 is being called the what? The leg length. It's from here to here. This is the leg length. The leg length is needed, as you will see when we go to the bar bending schedule. So from here to here, you have your leg length of this starter bar. Then the starter bar's leg length must always touch with this reinforcement here that is being shown as a dot. Now remember, I've included the bar mark here. This is bar mark 2. And when you come here to the base, we had given a bar mark 2 to this rebar. Now remember that we're cutting across like this. This is the reason why rebar, which has got a bar mark 2, is appearing as a dot in the cross section. Then at the bottom of this, you're going to have this straight line. It's being given a bar mark of what? 0.1. And remember that bar mark 0.1 is what we gave to this reinforcement that is running from left to right. Then once you've shown these, the next thing that you're supposed to show is the links. So links or stirrups are these ones that are going in this direction that are being tied to your what? starter bars. So you've seen the black ones here, from here to here, and another one from here to here. You only show 2 when you're doing your sketching. Then after that, you're going to create a dot here and a dot here. Then from there, you pluck out a line, you give it a name. So as you can see, we did a dot here, then we plucked out a line that is coming outside, then we gave it a name. Then the name that was given was 3R8 by Mark 4. Now, this 3 here was calculated. How do you calculate this 3? You get your length from where the radius ends for a particular starter bar. So for example here, you can see there's a turn here. Then on top here of this turn here, from here to all the way to the top, that's the distance that you are using in order for you to calculate your Your number of links that you're going to need. I'll show that in a minute. So here we have this, which is the name for the links. Then here you put 2 dots on your starter bars from here and here. Then you give it a name. Now starter bars, you will always be given the number that you are using. So for example, in this case, we're told that we're using how many? 4. Sometimes it can be 6 or 8, depending with what the person wants you to use. So for example, here we're using 4Y16. Then you say dash, the next number that follows is the what? The bar mark. So this is bar mark 03. Now, once all this is done, you've labeled your kicker height, you've given dimensions for your thickness 450, your length here 1500, kicker height 75, you've done your lap length here correctly. The next thing that you're going to need to do is the detail. What detail are we talking about? It's the detail for the top of this column. When you look at it from the top, then you section it. In short, here we could have the section that is cutting like this. Or if you want, you can call it like the way we've called it from the base here, called as what? Detail A. You point an arrow at this cube. Now this cube, when you look inside, what you're going to look at is these links that were being tied, the black ones here, they're going to be represented by this outward circle that you're seeing here. Then the starter bars are going to be represented by these shaded circles that you're seeing here. Then this one should be at a distance of 50 to the left, 50 to the right, 50 to the top, 50 at the bottom. Why? Because these are the concrete covers that you're leaving behind. Then after that, you draw the shell. This shell is your outside of your column, and you give its dimension, which is 300 by 300. Then remember that these shaded circles that we have here, they are starter bars, and starter bars have been given the bar mark of what? 3. So you're going to have 3, 3, 3, 3 to show that these belong to bar mark what? 3. Then this one, which is holding them, which is going to be the links, it's going to be given the bar mark 4, just like we've done here. So essentially, this is what you do when you're doing your sketching. This is how you sketch a pad footing. So all these details must be present in your sketch. After you've done your sketching of the pad footing, the next thing that you'll be required to do is the bar bending schedule. So the bar bending schedule shows you how the reinforcement is going to be cut. That is in terms of its shape code. It's going to show you the information of its length. It's also going to show you the total number of reinforcements that is needed. Then the number of bars that is in each, the number of members, the type of reinforcement that you've been using. So remember, we had this sketch, right? Now, we had given our reinforcements in this sketching bar marks. So for example, this reinforcement that is being distributed from top to bottom, we gave it bar mark 1. This one that is being distributed from left to right, we gave it bar mark 2. The starter bars here, which are these that bend out and go from the column to the base of the pad footing, we had given it bar mark 3. The links, we had given them bar mark 4. Yeah, good. Now, next up, we have this, which is the bar bending schedule, right? Now, when you're doing your bar bending schedule, you will be this top part will be given to you as a reference. Then you will need just to draw these bottom columns and rows. Then in the member here, you write the member that you're dealing with. For example, for us, we're dealing with a pad footing. Then the next column has what we call a bar mark. Now remember that we had given bar marks. So for example here, let's do a calculation for the bar bending schedule for this reinforcement that is being distributed from top to bottom, which has got a bar mark of 1, It's a Y12 reinforcement, and there are 11 of them. So on the bar mark here, we're going to put bar mark 1 because this reinforcement, this one from here to here that we're dealing with, has bar mark 1. Then on the type and size, we said this reinforcement is Y12. So this is why on the type and size we have Y12. The number of members will always be given to you in a question. So for example, they can tell you that you have got 6 pad footings, or 6 identical pad footings, or 4 identical pad footings, or 4 pad footings. It can be any number. So for example, in our case, we're going to have 13 pad footings. This is where the 13 is coming from. So the number of members is the number of that type of member that you're dealing with. So if you've been told, let's say for example, you're doing a bar bending schedule for a column. If you have 6 columns, on the number of members, you're going to put what? 6. So in our case, we're dealing with a pad footing, and we say the number of members we're going to use is 13. Then you have the number of bars in each. So the number of bars in each, it's the number of bars that are in that member. Now, how you calculate the number of bars, we had mentioned it earlier when we were doing the sketching, which is just this formula here, which is your length minus the concrete cover divided by 150 plus 1, you get 10.33, right? Then the 10.33, you round off to the nearest whole number, you get 11. This is why we have what? 11 here on the number of bars in each. You have 11 here. On the total number, you multiply the number of bars in each by the number of members. Then it will give you the total number of bars that are needed. So in this case, when you do 11 multiplied by 33, you get 1,400. Then, you get 143, sorry. The next thing that is required for you to do is the length of each bar. So now, to get the length of each bar, you need to first know it's what? Shape code. How do you get the shape code? You go to the BS4466, which has shape codes. So now, there are different types of shape codes. Then at the bottom here of this chart, you are going to have this, which is the minimum former radii bend and hook allowances. So here there is one is written grade 250 and grade 460. So we use this table here to get what we call a radius or an N or the H, depending on the shape code that you're going to be picking. The D here is the diameter. Even here, it's the diameter. The R is the radius. So now, on the grade 250, this is for the medium yield strength. Grade 460 is for the high yield strength. So now, if for example you've been given a Y16 rebar and you want to know its radius, you come here on the D, you come down, you look for where 16 is, then you check its radius, 48. That's if you are looking for that. Then if you are dealing with an R8 rebar, you come on the D, which is the diameter, you go to 8, then you check its radius, 16. That's how you'll be getting their radiuses. Then, if you are being given a bar bending schedule that has got a mass, the unit mass or the per linear meter mass of a bar is given in this table here. Then, next up, what you're going to have is the shape codes. Like I said, you have to look at how that type of reinforcement you have, how it's being bent. So if you have a reinforcement that is being bent in this manner, you're going to use shape code 54. If you have a reinforcement that is being bent in this manner, you're going to have shape code 79. If you've got a reinforcement that is being bent in a straight manner, like for example, in this straight manner, you're going to use shape code 20. So let's go back to our bar mark 1, since we're looking for the shape code for bar mark 1. Where is bar mark 1? You go back to your sketching. So this is bar mark 1, this one here. When you look at this shape, it's just a straight line that comes from left to right. So now, you go to your to your shape codes, then you check a shape code that has just a straight line. In this case, the shape code that has got a straight line is shape code number what? 20. Then a formula will be given for the length and how you are going to be calculating the length for that particular rebar. In this case, our length is just going to be what? A. So now A is just the length from one end to another end. So in this case, we're just going to remove the two concrete covers here. Then the remainder will be the length. So for example, here we have got concrete covers of 50-50. Now when you do 50 minus 1,500, so we say 1,500 minus 100, because we're having 50-50, you get 1,400. So 1,400 will be the length of the what? The rebar that we're dealing with here. So the length is going to be 1400, and our A, which is just the length, is also what? 1400. So that's how you're going to do for bar mark 1. We go now to bar mark 2. Bar mark 2, when you take a closer look at it, it's also just a straight line, removing the two concrete covers at the top and at the bottom. So when you remove your concrete cover, which is going to be 100 since you're multiplying by 2, since it's 50-50, when you do 1500, because it's along this span, 1500 minus the 100, you're going to get 1400, which is your A, and your A is also your what? Your length. So as a result, you're going to have 1400 here, 1400 here. Okay, so for bar mark number 2, like I said, it's just going to be the same. Shape code 20, your A is 1400 because it only has A. Alright, so next up, we're going to go to bar mark 3. So let's go back to our sketch. We look for bar mark 3, which is here. So bar mark 3 is our what? Our starter bars, or the main reinforcement of the pad footing. So these are the starter bars, the ones that are bending like this. Sorry, I had to pause the recording, so I've just resumed it. So like I was saying, we are now going to deal with bar mark 3. Then that's what we're using. Then, alright, so we're dealing with bar mark 3 here, which is Y16. The number of bars, the number of members, sorry, we have is 3. Then the number of bars in each, this one, like I said, the number of bars for the starter bars here, which is bar mark 3, they'll always be given. So here, how many do we have? 4 Y16 bars. So on the number of bars in each, we're going to have 4. The total number, it will be 4 multiplied by 13, 52. Then to find the length of each bar, you need to know first the shape code. So now, let's take a look at this shape. It's coming straight, then bends out. So we're going to look for a shape that is looking like this. Coming straight, then bending out. Come here. So we check which shape. Okay, so we have shape code 37. It slightly resembles it because it's bending out like this. Let's keep on looking. We see if there's anything better than that we can find. So there's nothing, right? So that means that the most applicable one is shape code number what? 37. Now shape code number 37 has elements A, B, and R. Your B is what we call the leg length. From here to here. That's your B. Your A is the length from the bottom of this rebar all the way up to the top where it's going to be ending. So when we come here, let me just zoom this in. Yes. So here we have from here to here, this is going to be our B. This is what I was calling the leg length. Now we were given to say that it's what? It's 500. Now 500 is only coming from here up to the face of the reinforcement. So you have to put the diameter of the reinforcement to this 500. So it's going to be 500 plus the diameter. This is the Y16, right? So we're going to say 500 plus 16. That's going to be 516 as our B. So here in this column for B, oh no, so this one had been using A, damn it. Alright, so now we're dealing with bar mark 3. The type and size, it's Y16. The number of members, like I said, 13. The number of bars in each, you come here to check for the number of bars in each. So here we're given that the number of bars is what? 4. So on the number of bars here, in each, you're going to put 4. 4 by 13 to find the total number, 52. The length here, like I said, you have to look at the shape code. So now, when you come to the shape codes here, you have to look for a shape code that resembles this shape here in blue. So when you come to your shape codes, the shape that resembles this, it's shape code number what? 37. Shape code number 37 has A, which is the shorter side, B, which is the longer side, and it has an R here, which is the radius. So now, A, which is the shorter side, in this case, in our drawing, it's going to be your leg length from here to here, because this is the shorter side of this reinforcement here. Then, you have been given to say from here to here, it's 500. But remember that your A is starting from the far edge of this rebar. As a result, you need to add the diameter to this 500. So it will be 500 plus the diameter in order for you to get your leg length. So your A is going to be what? 516, just as you are seeing it here. Next up, we have to find our B, because remember, B is the longest side. So in order for you to find your B is from this bottom part here, the bottom part of this Y16 reinforcement, all the way up to the top here. Now, in order for you to find this length, you will first need to remove the concrete cover, which you left behind here, which is a 50. So let me just get my calculator. So you're going to have 50 plus, then here you have this reinforcement. This reinforcement, it's a bar mark 1, and we said it's a Y12 reinforcement, right? So you add plus 12 plus. You check for these rounded reinforcements, you check their diameter. Their diameter, it's also what? 12, because it's a Y12. So you say plus 12 equal to, you get 74. Then your total length here for this base, it's 450, right? You'd say 74 minus 450, you get 376. So 376 is the length starting from here, coming all the way up to where the kicker height starts. So from here to here, that's what? 376. So let me just do this. So 376 is what we have, plus. Now, because here we're looking for this total length of our A from here all the way up to the base here. Then after you found that, so let me just repeat how we did the calculation. You remove the 50, you get your 50 plus the diameter of this rebar here, which is a 12, and the diameter of this rebar here, which is again another 12. You get your 76. You do 76 minus 450, you get 376. Then now, after you've gotten your 376, you add the kicker height to this, which is a 75. This kicker height here, plus you add now your lap length from the kicker height all the way up to the top, which is your lap length. The lap length here we got was what? 650 plus 650 equals, you get 1091. Let me just minimize the calculator. So 1091 is your B. Then remember to say you also have an aspect of what? Radius. So now this is a Y16 rebar we are dealing with, and it's a Y. So you come here at the bottom, where it's written grade 4 against the rebars. You come to where it's written 16. You check its radius here on R. 16 here. Here you get a what? A 48. So its radius is what? 48. That's why we wrote slash 48. Let me just show that I think it's not within the screen. So let me just enlarge this. Then let me drag it this side. Yeah. Anyway, so it's just going to be 48. So the R is 48. Let me just zoom out like this. So the R is what? 48. Then after you've gotten your 48, you go back again. Like I said, on each shape code you're going to have a formula that you use to calculate its what? Its length. So I'll go back to shape code 37. The formula is here. Now you can jot down the formula. So we go back here. We have our A and we have our B. Now, let me get my calculator. So now, on the formula it says A plus B minus 1 over 2 R minus D. A plus B minus 1 over 2 R minus D. The A, we have found it. The B, we also found it. Minus 1 over 2 R, which is your radius, 48, we have it as well. The D here is the diameter. So what you're going to do is you get your calculator. You say, what's our A? Our A is 516 plus the B, which is 1091 minus 1 over 2. All right, then now the radius we have is 48 minus the diameter we have is because the diameter will be given in the y. So like this is a y16, so the diameter is 16. So minus 16 equal to, sorry, I think I just did a miscalculation. But anyways, when you puncture them in, you do what's this, 516 plus 1091 minus 1 over 2 multiplied by r minus the diameter, which is 16. You're going to get 1567, which is here. So that's how you're going to do your calculations for this bar mark 3, the one that pins out, which are your startup bars or the main reinforcement of the pad footing. Then next up, you're going to have bar mark 4. So bar mark 4 is for the links. Now, in this case, the number of bars we had already been given to say there are how many? 3. So you have your 3 here on the number of bars, 3. Number of members, we have 13. The type and size, it's an R8. 3 by 13, you get 39, which is your total number. Now, to find the length of each bar, you need to come back here, check the diameters that you've been given, the dimensions, sorry, that you've been given of your column, the column part. So the column part we had was 300 by 300. These were its lengths. So this is 300 by 300. Now, you need to look at this, then they will give you an indication of what shape it's going to take. So for example, 300 by 300, this is definitely going to be a square. If it was 300 by 500, it was going to be a rectangle. When you come to the shape codes here, you have shape code 61. Shape code 61, you will only use it in cases where you've been given a rectangle, whereby you have one side which is bigger than the other side. Then if you've got two sides that are the same, you're going to use shape code 79. Where you have maybe 300 by 300 like what we have, you're going to use shape code what? 79. So now, when you're using shape code 79, it has a A, it has a B as well. So let me just go back to our bar bending schedule. So here where it's 61, you're going to use what? 79, like I have said, 79. Then, the shape code has a A and a B. The A, it's the length from the bottom part of the reinforcement to the top part of the reinforcement. The B, it's from the edge of the reinforcement to the other edge of the reinforcement. That's your B. And you also have an R here. The formula is given where? Here. This is your formula. 2A plus 3B plus 10D. So now, in order for you to get your A and your B, come back here. Let me go back to our drawing. Remember that these links, they are being put at a distance. For example, let's say we're dealing with our A from here to here. Here you have the concrete cover of 50. Here you've got the concrete cover of 50. So you do 50 plus 50, it gives you 100, right? 100, then you have your length here, which is 300. You do 300 minus 100, what are you going to get? 200. So as a result, you're going to have what? 200 as your A. 200 as your A. Then you come to your B. Your B is just in this direction. In this direction, again, you have a concrete cover of 50, 50. The length is what? 300. You do 300 minus 300, you're going to get what? 200. So it's going to be 200, 200. Forgive the 220, 220 that I wrote. So this is going to be 200, 200 here. Those are going to be your A and your B. Then the radius, like I said, you come down here, and this is an R8, which is a medium steel. So you come where it's written 250. The diameter is 8. Its radius is what? 16. Let me go back here. The formula has been given. Let me go back to shape code 79. The formula has been given here. So the instance is just on you, whereby you replace here, it's going to be 2 multiplied by 200 plus 3 multiplied by 200 plus 10. Then the diameter here, it's the diameter of the rebar that you're dealing with, which is just 8. So you're going to say 10 multiplied by 8 plus 3 multiplied by 200 plus 2 multiplied by 200. That's what you're going to do. Then you should get, let me just do it in the calculator here. Okay. Shape code 79. So it's 2. Our A, we said it's what? 200, right? Close plus our B, we said it's 200 again, and the formula says 3B, right? So we're going to have 3 open 200, close it, plus 10 multiplied by the diameter. The diameter in this case is 8. It gives you 1080. So here we would have had what? 1080. Not this figure, sorry for writing this figure. So this is what? 1080. So in a nutshell, that's what you do in order for you to calculate the bar bending schedule for the pad footing. And this is what you do if you want to come up with the what? With the sketch. So for any questions or any queries that you're going to have, just leave them down in the comment section. Thank you. Made mention to say, in this case, like I had said earlier on, to say the links were already given to say there were how many? 3. Now, in most cases, when you're dealing with a question, you will not be given the number of links. So as a result, you need to calculate them. So this is the part that I forgot to mention. So how you can calculate the number of links that are needed along this column or in this pad footing is that you need to come up with a length that starts after the radius of the starter bar, because remember that links are always placed along the starter bar. So these links are being placed along these starter bars all the way up to the top here. So now, in order for you to calculate how many will be needed, you need to get the what? The distance from here after this radius here. So the distance from here going all the way up to the top here. So now, in order for you to do that, what you're going to do is that you're going to come back here. Like I told you what you were doing in order to get your A, your B, sorry, here, in terms of the starter bars, when you are trying to get its B, the length here, from here all the way up to the bottom here. It's the same thing, but you're going to see the difference. So the first thing that you're going to need to do is that you're going to remove your 50 here. So when you do 50, you put it aside. Sorry, I had to pause the recording so that I can get the calculator. So let me start afresh. I said you get the distance from the bottom here to your distribution reinforcement, and this distance is just your concrete curve, which is 50. So you say 50 plus, you get the diameter of this reinforcement here, which is this was a Y12 reinforcement, that's 12, plus you get the diameter of these dotted reinforcements, which are got by Mark 2, and the diameter is what? 12. So you say plus 12, plus you get the diameter now of this reinforcement here. The diameter of this reinforcement is what? 16, because it's a Y16. So you say plus 16, plus you get the radius of the Y16 reinforcement, and that radius, I think we had found it earlier on. Let me just go and check it. 48, yes. So the radius of a Y16 rebar is what? 48. So you add the 48 as well, equal to 138, right? So the 138, you are now coming to subtract it from the 450. So you say 138. So I'll say 450. Let me do this. 450 minus 138, 312. So 312 is the distance from here, the top of the radius, coming to this top of the base. So in short, what I'm saying is, if I were to draw a straight line, just that I don't have drawing tools. So if I from here coming here to somewhere here, from here to here. So like I said, on top of the radius, that's the 312. So the 312 we are saying now plus the kicker height, which is 75, plus the lap length, in our case it was 640, equals, you get 1027. So the 1027 is the one you're going to use to calculate the number of links that are needed. Why? Because the links always start above this bend. So now above the bend, going all the way up to the top. Now, once you get this figure here, that was 1027, if I'm not mistaken. Once you get this figure, you are supposed to divide it by the spacing of the links. So in this case, I'll just assume that the spacing of the links was 200. So I'll say divide by 200 equal to that. Let me make that standard. Where is this? Alright, so boom, I get 5.135. Then after getting the 5.135, the formula tells us that we must add 1 to it. It gives us 6.135. Like I said, you round off to the nearest whole number. So now, the number of your links will now be what? 7. As a result, here, that's if we were not given the number of links and we are given a spacing of 200. Here where I have 3, I'm going to put what? 7. So that's how you calculate the number of links.